A particle P of mass 2.5 kg rests in equilibrium on a rough surface under the action of a force of magnitude x Newton acting up. So it is acting up, this is important, along the line of greatest slope of the plane. Greatest slope basically means along the plane. So slope, as you know, means gradient. Just greatest slope along the plane, it means just along the plane. That's all it means. So with the information that we have read so far, the angle is, we know, 20 degree, and the value of mu is also given. Coefficient of friction is 0.4. The object is in limiting equilibrium and it is on the point of moving up. That means the friction will move in the opposite direction. So this is all the information. So let's first draw this. So what we can do is, let me draw it over here. So this is 20 degree. This is the object. The object has a weight of 2.5 kg. So this will be 2.5 g for gravity, Newton, and it will have a reaction force over here. Reaction force is R. Now if I break this down into two components, one of the component is going to be mg sine theta over here, the other one would be mg cos theta. So this is going to be 2.5 g sine 20, and this is going to be 2.5 g cos 20. So this component is done. Now we have along the plane, so x Newton is along the plane, so this is going to be x Newton along the plane. We don't have to break this down into component because already along the plane. And we have friction. So since it is about to move up the plane in limiting equilibrium, friction is going to be in the opposite direction of motion. So let me write over here, this will be mu r. Mu is 0.4, r is unknown. So the diagram is very, very important. So let's do this. So this is going to be, we have to find the normal reaction r. So for finding the normal reaction r, we can just use normal to the plane. So normal to the plane, and that is going to be r equals to 2.5 g cos 20, and this turns out to, so 2.5 g, so g is 9.8 multiplied by cos 20, 23.02. So basically 23, because two significant figure, this is 23 Newton. So we found the value of the reaction force. So question number B, now we have to find the value of x. Now we have to take forces along the plane. So for taking forces along the plane, we know pulling it below towards the left is 2.5 g sine 20 plus 0.4 r. The value of r we already know, 23 Newton. I'm plugging it in there, and this is equals to the force that is pulling it upwards, which is x. So now we can calculate the value of x. So the value of x is going to be 2.5 into 9.8 into sine 20 plus 0.4 multiplied by 23, and that turns out to be 17.6 Newton. To two significant figure, it is 18 Newton. The force of magnitude x Newton is now removed, and we have to show that whether P remains in equilibrium or not. Okay, so in this particular situation, what is going to happen is we're going to have the same object, but this time the force x is removed. That means we're going to have this 2.5 g Newton. We're going to break this component down. So this is going to be 2.5 g sine 20. This is going to be 2.5 g cos 20. This is going to be reaction force R. Now since this force is removed, this object is obviously going to go down, so the friction is going to be, mu is always the same. the coefficient of friction depends on the surface quality, so that is the same, R. But the reaction will change because since this force is not there, so the overall effect is going to change. So now let's check how it is going to change. So we can see that vertically it is R, and along the plane it has changed, but normal to the plane it is more or less the same. So R is still equals to 2.5 G cos 20. So R is still, in this particular math, R is still 23 Newton. So I didn't calculate it because we have already calculated in the previous math, because nothing has changed for normal to the plane. Now along the plane, when we think about this, the main math is to see whether the force that is pulling the object downward is more, or whether the force that is pulling the object upward, which is more. Whatever is more, the object, we will determine whether it's going to be in equilibrium or not. First of all, friction. So friction is mu r, zero point 0.4 into 23, and this value turns out to be 0.4 into 23. So this is 9.2 Newton. So 9.2 Newton is the force that is being pulled upwards. Now the force that is pulling it downward. So downward force is going to be 2.5 G sine 20. That's the only force. And this is going to be 2.5 into 9.8 into sine. So 8.38. So 8.4 Newton to two significant figure. Now we can see that the friction is more than the downward force, and there is a concept known as maximum friction. That means friction will adjust until it reaches maximum friction. So if the maximum friction is 9.2 Newton, it can take a load up to 8.4 Newton. So we will say that the object will be in equilibrium. So P will remain in equilibrium.